Okay, welcome back. So we're just going to browse through chapter 1. So you've got your text, the answers to the text, which you can jump into quite quickly, more detailed solutions, and much of them are not a waste of time looking at compared to your own work. Some interesting applets, looking at the difference of two natural numbers, the square of natural numbers, looking at a series of natural numbers through a fixed power. So for instance, take 2 to the power of 1, 2, 3. So there's a base. Yeah, so if you want 1 to the power of 5, 2 to the power of 5, etc. Of course, the ones you'll be most interested in is, say, when that's set to 2, when that's set to 3. So these are the squares. These are the cubes, and so on. Okay, this just decides where you start, so you might like to leave that set at 1. Don't seem to be anything in there. We have very nice app to help us to understand that the vast majority of square roots are irrational. But every now and then we hit upon a number which has a integer root. So there's 4, 9, or at least, yeah, there's the square root of 9, and then you get up to the square root of 16, etc. It's a nice little fella. Just a little applet that will just factorize numbers for you very quickly. So you can take control and it'll do up to very, very big numbers. And you just key in your number there. You have that facility in your calculator, obviously, but it's nice to bookmark this and have that available. So say 1001 is the product of 3 consecutive primes, which is interesting. Okay, the spiral of the Pythagorean spiral, quite interesting, very important on the course for constructing square root of 2 and square root of 3. And don't get that confused with proving that square root of 2 is it's proving that the square root of 2 is irrational. Okay, moving on to something that we actually need to do. So there's the syllabus, and in particular we can look at its aims and objectives here. Now this is for strand 2. So I've just highlighted a few simple things here. The fact that 2D representations of 3D solids to solve simple and multi-step problems in numerous. So that's effectively chapter, my understanding of that is that's chapter 18 in your books. So that belongs here in the number section. Okay, now this is not the overall aims of the syllabus, this is the aims and objectives of strand 2. You want to look over them in your own time. Okay, and you'll have seen the word synthesis used quite a bit. So I just want to quickly just talk about what's the difference between what's the role of synthesis in problem solving. So synthesis entails the act of creating something that did not exist before by integrating information that has been learned. So despite the fact that you've gone through your book and you've learned each and every section, you haven't synthesized it unless you've grown a rich mesh of connections between them all that you can use when you're problem solving to navigate through problems. So when you put together all the individual skills that you've learned, when we put together a whole series of skills, we say that we are synthesizing those skills. Okay. So just this will be the ordinary level objectives. Sorry, learning outcomes. Appreciate that there's a difference between real numbers and irrational numbers. Work with irrational numbers. Square root of 2 times square root of 3 equals square root of 6. That should come naturally to you. Revisit the 4 main operations across the main number sets that you know so far, and then you'll introduce the complex numbers to that, so you'll be able to do similarly for complex numbers. Okay, we're going to be doing this in chapter 1, all about prime numbers and lowest common multiple and so forth. PEMDAS, and then writing numbers in index form. Okay, a little bit about sequences, and we push on to the higher level. So the construction, root 2, root 3, I showed it to you there in the Pythagorean triplet. A proof that root 2 is not rational. You'll be going through that line by line, you'll be studying it. It's very, very popular in exams. Okay, and calculate conjugates of sums and product of complex numbers. You don't have to do that right now. You don't have to do a lot of this right now, actually. It's not really in your first year. And you certainly have to do these basic things. Use the equivalence of fractions, decimals, and percentage to compare proportions. Okay, that'll be quite easy. Consolidate your understanding of the multiples and prime numbers and the relationship. Order of magnitude. Okay, so I call that the common sense test here. And then a tiny bit about indices and logs will be coming up in the numbers as well. So let's look into the first exercise. Sorry, there the answers. Alright, just need to navigate back here to I got to go into a sub-page there. So the key to this chapter really will be the fundamental theorem of algebra, which says that every integer greater than 1 is either prime or a product of a unique product of primes. Okay, we'll just jump straight in. You'll understand how that works. You should know that by now. Okay, so basically to express 1, 2, 6, so just going to look at the result we got from the calculator. So it's 2 squared, 3 squared, 5 and 7. But just so let's look. So we know there's 2ness in there, 3ness in there, 4ness in there. I'm going to call it because there's 4 in there. There's something to do with 9 in there, and there's a 5 and a 7. What I want to do, which is more interesting, is to quickly talk about divisibility. How do we know that the number divides 2 divides the number? Because it ends with an even. How do we know that 4 divides the number? Okay, well, you just have to look at those 2 digits, and indeed, if this is even, then you're looking for 0, 4 or 8, and if this is odd, you're looking for 2 or 6. Well, that's quite important. How do we know that 3 goes in, the digits add to a multiple of 3? How do we know that 9 goes in, the digits add to a multiple of 9? How do we know that 5 goes in, it ends in 0 or 2? And here's a cool one. How do we know that 7 goes in? Double that and subtract. That's a bit boring. And then keep doing that until you're comfortable. Double that and subtract. And if you end up with a multiple of 7 here, in fact, if you keep doing it, you end up with 0 here. So if you end up with a multiple of 7 here, like 91 is an example, double that and subtract and you get 7. So 7 goes in. Now, to the best of our knowledge, you will not be forbidden from using using the calculator to do that. Okay, so you'll always just be able to go 1, 2, 6, 0, But we're going to show you some calculator tricks towards the end of this, which you do need to be careful with, because sometimes the wording forbids you using the methods that the book shows you, and I'm going to show you here as Google. Okay, so that's that question, that example done. Okay, so I want to show you the long drawn out version because it's quite important, and it's going to have it's going to have big payoffs in algebra. So it goes like this. What we want to do is we want to write 12 in powers, factorize 12 and write it in the standard way we tend to write it. Okay, so 12 will be, your calculator will tell you it's 2 squared 3. Now in particular, I want you to consider leaving space for any bases that may show up. So these are the first few prime numbers. You normally won't have many more than that. Okay, so if I'm writing 12, I'll be talking about 2 of them and 1 of them. If I'm writing 18, I'll be talking about 1 of them and 2 of them. If I'm writing 30, I'll be talking about 1 of each of them. Okay, so when it comes to finding the highest common factor, and remember this is a lowish number, what you do is you scan up through that and you take the lowest power there is, which is 2 to the 1. You scan through that and you take the lowest power there is, which is 3 to the 1. And you scan through that, and then I can sort of say, well, that's 5 to the 0 and that's 5 to the 0. Now that's kind of higher order thinking, but there's basically the lowest power is nothing. So we end up getting that the LCM equals 6. Okay, moving on to the next one. That's the highest, the highest common factor. I wrote that wrong. Okay, it is the highest common factor I calculated. Okay, we do the same again. Find the lowest, this time we wanted to find the lowest common denominator. So let me just get rid of that, I don't need them. Let me just set that information up again here. Now this time it's the other way around. This time you're looking for the highest power. And that then would come out to be your lowest common multiple. Okay, so that is a multiple that that all 3 numbers go into. Okay, and you have 4 9s 36, 5 of them is 180. Okay. Now this is where there's something wonderful to show you. So I'll wipe that. We'll get into the next example here. So by using a calculator, find the biggest common factor and the lowest common multiple. So here's the calculator trick. So the other trick, the long drawn out way will be to write the factors of 432, write the factors of 256, and do what I just told you there. For the highest common factor, you take this is the weird one, you take the lowest powers in each row. Take lowest powers, and in the lowest common denominator you take the highest powers. But either way, we've got a way better way of doing it, and it goes like this. So you put 432 over 256 and you see what your calculator tells you. Okay, and that's equal to 27 over 16. Now you divide 432, you can either divide those two or those two. It's going to be the same answer. Okay, and that's going to be the highest common factor. Every time, provided you just 2 digits, it's that easy. Okay, so now all I need to do is 432, and by the way, this is explained to a certain extent. It's given in the book. I don't know how to explain it very well, but then that turns out to be that 16 is actually in both of them. So that 16 divides into that. Now don't be put off, the highest, yeah, you see 16 16s is 256 and 16 27s is 432. Okay, the thing is we have our answer, highest common factor equals 16. Now here comes another very cool trick. For the lowest common denominator, you can either use that or that, and they're both the same. Okay, so 432 by 16. And I hope you can think about it and understand why they're both the same. Let me go around the house here and put a 4 there. Okay, I get 6912. Okay, that's it. That's all we had to do. Well, there is one more thing I'd like to show you. So we've just found out that the lowest common denominator equals this. So I also want to show you that when you multiply them together, you get the same answer if you multiply the two original numbers together. Okay, so 16 by 6912. Is 110592. And sure enough, 432 by 256 will be the same, and I'll leave it as an exercise for you to check out why that is the case, based on the algorithms from how we worked. Okay, that could be very important. That's an important piece of synthesis you do there, because that could be very important when you're in the middle of problem solving. And remember, number is a fifth of your course, so you mustn't neglect it. And there I'll just be confirming all my answers there. 6912 as we got. Okay, there's just a few further resources for you to explore. Now we're going on to chapter 1. So questions 1 to 2. So you should be able to do them. I'm not going to do them for you. I've made an extra video there as well on top of this one that shows you how to do that again. But really, they should be quite basic and simple for you. Okay, so to find the highest common factor, I'll just do the first one there. Now, which number you put on top doesn't really matter. But let's try and figure out as we're going, and that's where problem solving. I don't really know yet. I haven't done enough of these, to be honest, which is crazy. So we'll try to figure out which do we prefer, the big one on top or the small one on top. Okay, so we go ahead and do that calculation, which is 5/4. Now, 45 divided by 5 is 9, and 36 divided by 4 is 9. So 9 is the answer. Now, sure enough, we've been able to do that by inspection, but I won't be able to do them all by inspection. 90 over 144. Let's put the big one upstairs. over 5. Okay, and then you divide 8 into 144. Or divide 5 into 90 is easier. So you take your pick there, which one is easier, and 5 into 90 is 180. Now hold on a minute, am I getting the highest common factor or the lowest common denominator? 9 is the answer. You divide that into that. Sorry, what do I have there? I had 144, 90, 8 over 5. So 5 into 90 is 18, and 18 is the answer there. So for these, we want to find the highest common factor. So I'll do the last one, and I'll let you do the rest. I'm going to lay out, and it'll be a good bit of calculator work here. Lay them out like so. And remember, just because we see the word highest, we're going to be take the lowest. Okay, so 176 gets factorized. Which is 2. What happened there? Oh, where have I a glitch? 176 equals factorized. Okay, 16 times 11, of course it is. So 2 to the 4 times 11. Now you want to leave lots of space for all the other prime numbers that are in there. Next we have 198. Yeah, 198 will turn out to be 2 times 3 squared. So I'll be putting the 3 right next to the 2 times 11. And 330 will be 2 by 3 by 5 by 11. So now I want you to think very carefully about this. Take the lowest power. The lowest power of 2 is 2. The lowest power of 3 is 3. And the lowest power of 11 is 11. And this guy does not contribute. Okay, so then the answer turns out to be 66. For the highest. Now it's the highest common factor uses the lowest. Okay. Now here's a trick that's also quite rich when there's 3 of them. Here's a brilliant trick. I think. What am I going to show you? Well, I might be wrong, but let's try this. If you multiply those together and divide it by this, you get the lowest common factor. That's what I'm going to claim. I'll check it later. So you take your calculator and divide by 66. So you go. So it's a way of not redoing the algorithm that takes the highest powers. Actually, there is a lovely way to check it. So we are going to do this, and it's a fantastic bit of exploring. So 176 multiplied by 198 multiplied by 330. Okay, gives us some huge number. Divide by 66 gives us 1742. 42, 40. Now going around the other way, I would have got 8 as the highest power here. I would have got 9 as the highest power here. I'm very worried now that my method is rubbish. I would have got 5 here. And I would have got 11 here. And I cannot imagine that multiplying up to that level. Highest power, highest power, highest power. That should have been a cube. But maybe it is that only works when there's 2 numbers, and I'd have to think it through. And there was no 3 up there either. So that number shouldn't have been 66. So look, I made a mess of the video. I'm going to post it anyway, and then I'm going to start a fresh one which might be a bit cleaner. But by being adventurous and exploring, I discovered I made a mistake, which in itself is probably a good point. Of course, you don't like seeing people making mistakes, but you can see you've seen me making mistakes, and I often, just for being enthusiastic and interested in exploring, I end up finding that there's something wrong, which I've done here. Actually, better still, I'll just keep going and fix my problem and just keep making the video. So I discovered 66 isn't right. And we discover that because I don't know where I mysteriously came out with 3 here. I just did the algorithm incorrectly. So what I should have been doing, as I'm looking for the highest, is taking the lowest power. So the lowest power was simply 2 and 11. So 22 is the answer for the highest common factor. Okay. Now for the lowest common multiple, we have 2 to the 3, which is the highest power there. the highest power in the next slot is that, the highest power in the next slot is that, and the highest power in the next slot is that. So that's 8 nines 72. 72 by 11, by the way, let me just show you this, is that you add the 7 and the 2 into the 9, and you multiply that by 5, which is multiplied by 10 and half. Okay, I'm stretching myself here now. 35. What's half of 79? Okay, without the calculator, you could say once I've had to use the calculator, you could have gone back to 8 by 9 by 55, which is 3960. Okay, now I wasn't asked, but why not? Why not get the lowest common multiple? And what I want to show you is that may also have come out, and if it doesn't, then I'll have learned something, and I'll have to do some analysis to see why. You can have a hunch about something, you can try it out, but analysis is when you look for deductive reasoning, why it works. You know, really try and prove it. So 176 times 198 times 330, and I can't see that. That just looks way too big. But if I divide that by 22, okay, so it must be only when there's two numbers that it turns out that the LCM times the highest common factor turns out to be the product of the two numbers. Okay, maybe that only works for two numbers. And I'm glad I explored it because I learned something. At least I ruled out something. That's the first one, just the some of the work done for you there. So we'll use the calculator method because it hasn't told us not to use the calculator method. So with these, just put, say, the big one over the small one. You put the big one, small, sorry, 21 over 24, okay, is 7/8. So this is how it works. 21 over 24 equals 7/8. And then you divide that by, you divide either the tops or the bottoms, it doesn't matter. Okay? But now, so to get, and again I'm wrong because that's the highest common denominator I've done here. So really, so the thought process is it's at least some loose kind of safety net is the lowest common multiple is a big number, so it'll be 8 by 21. And you can see I have to do lots, you have to do lots in order to synthesize over time your understanding. So 8/20s would be 160, so 168 is the answer there. Okay, this time I'll go 64 over 48, and I would just preempt. Preempting is just knowing where you're going. So furthermore, I'll do cross multiplication when I'm finished here. So we'll clear the text. Hitting that does clear everything, by the way, just noticed. So 64 over 48. Hit your equals, and now 3/64. Now don't leave that go to waste. Write it down, and then you could also go forward. One of them might be easier than the other. I see 180, 192 going this way, and of course we have to see 192 going this way too. So you can practice your mental maths. A lot of fun. 4/40s is 160. 160 and 32 is of course 192. I'll leave the rest to you. The rest of those ones anyway. Let's go down and look at the next exercise. Find the lowest common multiple. So we've abandoned any fancy tricks about find the lowest high. Now I am curious as to, could you find the lowest common multiple of those two and then those two, and then could you combine? But I think the simplest thing to do is just slog it out with them all. And anyway, we do want practice doing this thing, understanding that because of number theory, the lowest will be a high number, and we'll be take highest powers as you run down like this. Okay, so I might be able to just speed things up a little bit by taking because getting the prime factorization is a pretty trivial business. You can't really go far wrong once you know how to do it. So you're going to get 2 squared times 3. Now look for a gap, because there might be a 5 and a 7 in the other numbers, and there's no need to look ahead, just leave gaps. 154, sure enough, I need a 7. Well, and don't put it there, put it there. Okay, and put it somewhere into blank space, and then your 11s go here. And 176 has 2 to the 4, and it has 11. Now, as I say, I'm taking the highest power in each case. So I have a 2 to the 4, I have a 3, and a 7, and 11. Okay, now, of course, you put all that into the calculator, and you get your answer. Now, that's 21. 21 by 11 is 2, 3, 1. And then I'll multiply that by 16, and I will do that with the calculator. Or you can do the whole lot on the calculator. I just show you little bits of numeracy tricks. You can take it or leave it. So all you're doing is you're multiplying out. And there's a 2 to the 4 sitting back here that you can't quite see with the calculator on. Okay, so you're multiplying them all out, and it's the same as 231 by 16. And just for fun, I'm going to do both, just to make sure that I did get it right. 30, this is going away. So 3696. Well, that's the answer that was given in the marking scheme. Of course, you won't have that as a backup in the marking scheme, but that's that done, and that's enough. I want you to do the rest. Now, in this, as a product of prime numbers, hence find, yeah, but we know how to do that, and to do both. Now, I will just say this one could be done more or less by inspection. Like factorizing 45, I have 3 squared 5. Factorizing 54, what is 54? We know it as what? 6 nines. Well, the 6 gives us a 2, and then there is 3 cubed, because the 6 gave us a 3 and a 9. Now I'm going to push the 5 out there. And we're heading into 63. What is 63? 7 nines. Okay, so we're pushing a 7 out here, and we're having 3 squared here. Okay, now we'll introduce just 2 lines here, one for the highest and one for the lowest. Now the funniest thing about the highest common factor, again, is the low one. In terms of the low one, you see I need to keep my ducks in line, okay, and I also want to keep the colors consistent, just for no particular reason. So if I'm looking for the lowest power there, I get nothing. The lowest power here is 3 squared. The lowest power here is nothing. Now that doesn't mean 0 reduces it. This is not a 0, it's a 1, it's 5 to the 0. And the lowest power here is nothing. So 9 is the answer to the highest common factor. And now for the lowest common multiple, I'll pick off a 2 here. If it's just on its own, it's the one that goes in there. Here 3 cubed is the highest. You can fill it as 27 now, or 3 cubed. And here we get a 5, and here we get a 7. The 2 5s is definitely 10. I don't want to do 727, so I want to go to my calculator anyway. But I will do 70 on the first and the last 2. Okay, so it's 27 by 70. So I'll do a little bit maybe to speed your work up. It's very hard to get through a paper in time. So I'll say it again, 70 by 27. We don't do any mental maths if there's any risk that you're making a mistake. So that's 1890. Here's the great check. The is the product of those. Oh yeah, I see why. It only works for 2 because the low one. Yeah, I can see why that doesn't work for 3, and that's fine. So I don't see any particular quick check, only to tell you. Mine, 630. Made a mistake there. That should have been 630. What happened? I had a 2. That was 54. I think this cost me not to go into the calculator. Is that not 227? Which is not bad. I think the book made a mistake there, guys. Because the highest power of 3 is 3 cubed, not 3 squared. Okay, so I think we're good. Let's check that real quick.